catered towards understanding the architecture, understanding the problems you're going to face, and how do we take care of those issues. All right, so what are we going to cover? We're going to start with the enterprise architecture, what that looks like, what's the domain looks like, what are the criteria you need to keep in mind in terms of performance, in terms of availability, all the agilities you have got. So we'll discuss that in more detail. Then we look at the microservices issues, how that really ties up to the enterprise architecture, and resiliency, how we build the resiliency on top of it. Now, linking these applications are important also. So we'll talk about what are the different patterns to link these applications. And at the end, we'll look at MDM and also security. So those are the kind of like 4 or 5 things we're going to discuss as part of our journey today. Right? Are we all excited? After food, yes, where is excitement? All right, so let's dive into it. So if you see this model, like, the integration pattern which you're looking for is, if you think about it from your perspective, this portion is a separate application. This portion is a separate application. How they link to each other. How many here has problem with data? You have the data, but the data is not clean. How many here has that problem? Yeah. So that's a major problem like a lot of people have. And the ERP solution, now you got an order, but that order is created, but there is no inventory for it. Yeah. So that's another problem which comes in integration patterns. Another thing which comes in is like, hey, the person is trying to buy $1 million order. And this actually happened in one of the clients. The person logging in got the cart ID. Using the cart ID, they are trying to try different credit cards to say whether the credit card is legitimate or not. So they're using guest checkout, and then they're able to use it like, hey, run that through. They were using the same card ID with $1 million transactions. So, which is not possible, but like that can happen with anyone who's kind of using the system. So we'll talk about all these things as part of our journey today. And this is between different clouds, public cloud, private cloud, microservices you're building on one side. All these are linked to each other. So what things are important? These are the 5 things I consider as important, okay? Number 1 is empathy map, understanding the customer. Number 2 is read and write. What is your read and write? How fast you are reading and writing the data. Performance and cost optimization and timeline. So that said, first we need to understand the user. So when we say user, it means both internal and external users. So that means if you have, you say that, hey, I'm focused on the external users, that's fine. But how your operation person is using it, how your manager is using the system, or system manager is using, that is the critical part for us to understand. Next thing is, you need to know how many read queries per second. Now, I'm going to elaborate a lot more than what we have here, but I'll give you an understanding on this. So tomorrow, I have a talk at the end, which talks about the system design. Please come to that if you want to really get into a much more detail on this one. But read queries per second. How many queries you are reading per second? How much data you are querying per second? So this actually identified how many servers would you need, and then you will also know how much views you are having at that same time. So you need to make sure you have the right capacity to perform these operations. So this is where the spikes comes in. So what I normally say is that you always find out what? Average load. Once you find out the average load, so don't find out the peak load. Peak load, you can't design for the peak load. So you have to design for average load. But then when you are designing for average load, 10x the load. So the one thing which I always suggest is do a 10x. 10x means whatever is your average load, you 10x that load. So that's a 5x or 10x. These are the 2 parameters which are there. And your application should be able to sustain that load. Make sense? So that's what we do in the scalability aspect of it. Now, the next thing is performance. When we say performance, then, when we are looking at from our perspective, and I'm going to just show you here. So you are trying to put data in one system. And then you need to also read that same data. You know, when you have an eventual consistent data is there, you want to read that data. There is always a right to read data delay. Yeah, you need to know what that looks like. Is it 1 minute? Is it 10 seconds or 30 seconds? You need to know that data delay because that's the delay you're going to have for using the system. What is P99 latency? What does that mean? Anyone? What do you think this means when we are working on it? So what it is saying is that don't look at 100%. So when we are saying network can go down anytime, yeah? So network is not reliable. So what this is saying, only look for 99% of the latency. That's it. Only look for 99% of the traffic. So you're not going to, so let's say 99% your response time is 230 milliseconds. For the rest of the 1%, it will be much higher. You know, so it will be like, you know, for example, sometime I have seen 30 seconds to load the data. You have to ignore that because network can go down anytime. If somebody is asking for 100% efficiency, you will never be able to achieve. So that's another measure which is there. And then, of course, availability. How much is your system available at any given time? Based on that, now you're trying to predict here, what is your context diagram? So context diagram is important because you want to find out who is interacting with me. So this productive system, I'm having a clearinghouse, which is now, I'm having a product catalog. You search for the product catalog. Now you're using that product catalog, and then now you want to find out there's no fraud associated with it. So all those details you're going to get out in this case. Yeah. Now, what happens in the big data perspective? Now, this is from 2019. These measures are from 2019. Now, what this is saying, 64,000 stories, Instagram stories are pasted, uploaded. I think you can double that number now because after COVID, like people are using more Instagram. So, tweets, 500,000 tweets are happening per minute. So, how do we scale for that? So that's another thing which always comes in for us. Now, when we are doing big data, what we are looking for is, can you guess what's the amount of data I'm talking about here? Anyone? Just keep your guess on. What's the amount of data here? Huh? Petabytes of data, exabytes of data. You can say exabytes or petabytes of data, you know. So that's what the data is. What's the data speed looks like? What do you mean by data speed? What does it mean? So what's happening is that, you know, we used to do real-time processing. So real-time processing, what we used to do was we used to do an ETL process here, yeah? Earlier, there was an ETL process. You complete from here, send it from here till here, yeah? We're all familiar with that. Like 20 years old technology, we used to do that. Now what's happening is you want to do real-time analytics. Real-time analytics, you need to use Spark and Cassandra to really process the data. That is where the velocity comes in. So you have to make the decision near real time. Fraud detection near real time. You know, that's what you're trying to do here. So variety of data. This could be an XML format. This could be a JSON. This could be many other variety of formats is here. But then what you're looking for is the quality of data. What is your quality of data looks like when you are moving from one system to another system? Let's say you have a CRM. You are going from CRM to ERP. What is your quality of data? What that looks like. Now, another thing which is very important is that what you're really looking for is 80% confident this is a fraud. Okay? If you're looking for 80% confident this person is going to buy this product. So why don't I do more selling to that person so that I can sell the product? So that's another thing which is important in this case. Another thing is the variability. So when I say variability, can you give me an example on variability? When we say variability on the data flow, what's really happening is you're starting from one system. Let's say you generated a lead. After lead, you generated an opportunity. Okay? Opportunity generated now. So think about it. Opportunity generated. Now from that opportunity, you got a sale. You generate what? Order. Once the order is generated, so this is important to understand. Once the order is generated, then the CRM solution will not have the data. Now the ERP solution will keep the order. So who can update the order? If somebody asks you a question, who can update the order? Before the sale took place, CRM. After the sale took place, who can do it? ERP. So that is the logic which we have got. That means the data has a variability with respect to the data flow at the status of the data, where it is belonging to. Okay? When somebody comes in, hey, I need to do an oil change. You know, you guys go to what? You go to the oil change person, yeah? And then what do? What's the first thing they do? They look at the oil change, but they also look at other things, engine light and other things. They said, oh, what do they do is they're doing cross-sell. They're saying that, hey, I want to generate more revenue for myself. So what they say, they create another opportunity, which is called cross-sell. You generate an order for that and then get a sign-off from them. That means you're increasing your serviceability. The data is getting populated. Hey, you're due to do these things, yeah? What is that? That's called upsell and cross-sell. So those are the things which you're doing in this case. Another thing which happens is, if you think about it, the big data started. If you think about the big data analytics, abstract, transform, load, we are doing it since 2000. This is not like something new. But now what's happening is, now this has changed. This has changed in terms of social, sentimental analysis. For example, is somebody saying bad thing about me? You know, every company is doing sentimental analysis. Like, even if you know it or not, you want to make sure who's saying what in comments for me. So that's something is also big data. But now real-time analytics are coming in. You are passing by, you have a mobile device. Now what's happening? You are getting a coupon based on the geolocation coordinates of the store and be able to use the system. So that's what's happening in this case. So that's where the real-time analytics comes in. So when we are doing that real-time analytics, how do we do that? That's the question which comes in. So we are doing either real-time staging the data, you stage the data and then you perform the data. How many here you have done ETL process, yeah? Pretty much everyone is doing ETL right now. Like, you know, I think there is a process, you're doing a database transformation, you're transforming the data and then loading the data. The problem comes in the transformation is what? What are the kind of problems you face in the transformation? Anyone? What kind of problems do you face in transformation of the data? What do you think? Types of data. Transformation means, like, you know, your date formats are not matching between the two systems, yeah? When you're sending the customer data is already here. How do you merge that data? So that's all those problem comes in, and we need to solve that. So ETL process, as we can say, is like, you know, your check clearing system, you can say, you know, and then credit card transactions you want to do. You want to reconcile the data between the two systems. But real time, now you're saying point of sale terminal, reservation system. So that's where the real time system really comes in. Now we're going to get into the problem statements of integration between the different systems. So I'm going to talk about the first problem is from the microservices area. So one of these problems is that, hey, I want to, let's say I want to get a ride. Let's just pick one thing. I want to get a ride. When I'm getting a ride, what's really happening is this. So when I say I want a ride, it goes in through the API gateway, yeah? It now goes in, and then we are now going to find out whether any driver is available or not, yeah? And then I'm going to find out, like, hey, if the ride is available, give them points, you know, point system, or you create other systems which are there. Could you tell me how am I going to do this? So I'm going to call these APIs, you know. I'm going to call this API. I'm going to call this API. What is wrong in this architecture? Anyone? What do you think is wrong in this architecture? Too many HTTP calls. No, this is one HTTP call, but there is orchestration API which is doing these calls. Huh? Single point of failure. So this could be SPOF. Yeah. What is the other problem here? So that means this service can go down anytime. Yeah. So if this service goes down, what do you need to do? You need to apply a circuit breaker. Yes, circuit breaker you need to apply, you need to retry. But yes, you do the retry. All those things are good. I want you to do those things. But what is still the problem in this? Huh? Synchronous, yes, that is a major problem. Sync transaction is there. That is a major problem, looks like here, yeah? But what can you do to protect yourself? Customer wants a product. They're just saying, give me this product, give me these 20 products. You don't want them to say, sorry, I can't take your order. Hey, you want to do that? No, not to the customer, yes? Internally, how you solve it, they don't care how you solve it. So what is wrong in this architecture?
Queue system.
Huh?
Queue system to put in the orders.
Queue system to put in the order, but the other problem is that, you know, before you put the queue system into the order, you have to save the data somewhere. You see? So what happens is the orchestration, something goes wrong. Orchestration, you lost the whole data. So the first thing I always suggest is save the data. Okay? So what do you need to do? Data. Once you save the data, now you're golden. You know, now you have data to come back to and you can replay that data. So queue you can use Kafka or something you can use to do that. But storing in the database is fine too, from my perspective. But now what's really happening is, what we are trying to do is we want to store the data and then return them 202. Thank you for your order, we are processing the order. If you call Amazon, you know what do they do? First thing what they do? Anyone? Thank you for your order. And second thing, do you know what they do? No, they get the money. There's a second thing they do. You go in, they charge you right away. Yes, they have the product or not, who cares? They're going to charge you the money. So that's what you need to do to make sure you are protected. So that's where the resiliency comes in. So resiliency model is like, you know, hey, I logged into the system. So I'll give you another scenario. And these are actually problems I'm discussing right now. So somebody wants to create the order. You're applying the coupon, I did the order. Hey, I want these 20 items. Yeah? After the 20 items are added, I have two choices here, guys. Okay? One of the choices is that, hey, I can send the data to inventory solution. So that's one solution which could be there. Yeah? So I could send the data, means I can push. I can push the data to inventory. Hey, I got a new order. I'm excited. I want to send that data. How many here do that? Point-to-point integration, we do that, yeah? We send that data, hey, I got the order. I want to call the ERP API right now so that I can send that order to the ERP API and they get an acknowledgement from there and I'm good to go. Yes? What's wrong in that problem, in that architecture? What do you think? Huh? No, customer details are there. There are customer details. Customer details are all there. Think that they're all there. That's not the problem. That's not the major problem. Inventory. Inventory might not be there. Inventory might not be there. What is the other problem? Huh? Payment might fail, yeah. All good problems, yeah. What else? There is a major problem here. See this. Let's say there is a Black Friday. You guys, everybody know Black Friday or like Diwali festival, you know, everybody wants to buy gifts, yeah? This is a new gift we need to buy. So Black Friday is there, you know, everybody knows because it's like, you know, a lot of companies are from US and other places. What happened at that time? You're going to get orders, you're going to get 1 million orders. Now you get 1 million orders. Now what are you going to do when you get the 1 million orders? Now you're going to push that order to inventory solution. Now what happened in the inventory solution? Unable to take that request, yes? So that is a problem. Yeah? How can I fix this? You can scale up, you can add more servers to the inventory solution to do that. But really speaking, you can't really do that often. So what you use is the pull solution. Pull solution is that, hey, I got an inventory. You know, I'm working on the inventory now. So this is my warehouse, okay? In this, if you've seen in Amazon and other places, they have robots moving from one place to another place, yeah? So they know their capacity. They can process, you know, 200K products per hour. Per hour. Yeah, they can process that. Now 200K is there. They can't go more than that. So what they do is they pull only 200K, process them, and take the next 200K. Yeah. So that is what is called as pull model. So that's another model which people are using to protect themselves. Because you want to increase the customer satisfaction. And with saga pattern, what is this? This is saga pattern behind the scene. You're pushing the data or pulling the data. You want to make sure that transaction goes through at the end of the day between 3 or 4 systems. It's not like one system I'm talking here. Yeah. So now what happens is, now you did that, inventory goes down, and we discuss what can we do in that case. Now you may say, hey, I want to do load balancing. Okay, do load balancing. So what's really happening? Everybody know load balancing, how that works, yeah? So you're going to have one request going from here, second request can come from here, so you need to cache the data. You want to put it in a cache, yeah? So that's one thing you can do here to protect yourself. That's not the problem. The problem is that if this goes down, this server goes down, you have to route the traffic from here. Yeah. So infrastructure-wise, you have to maintain the load balancer with these settings, and then you need to do auto-scaling group. You have to add the auto-scaling group. You have to scale your system. Yeah. Now, what happens if you add new servers? Now, consider this. Let me explain you. This is not one server. Okay. Let me explain you what this is. Take a look at this one. This is a combination of co-located API microservices. Okay, they are all co-located, and this servers auto-scaling group needs to add all these servers at that same time. How long does it take to add that server? All these servers needs to be added. Yes. How long does it take? 5 minutes. 3 to 5 minute minimum, yeah? You're not going to take more than that. Now, even if you're planning to increase the peak load, how can you plan for peak load using this? You cannot. You cannot do that. I mean, what I'm saying is you have got, let's say you are processing 20K requests coming in. 200K requests started coming. Can you process them? No, you can't process. Can you add auto-scaling group? You can't add auto-scaling group. Can Amazon add more than 65,000 servers on a VPC? No. They have limitations also. So you can't do those things. So this is a problem. I'm defining problem. Solving it will solve in 5 minutes. Okay? But this is a problem, real problem you're going to face when you are doing the scale out latency, which always comes in when you're working on it. So should you design for the peak load or should you design not for the peak load? Not for the peak load. Yeah? But see, the thing is that your product owner comes back and says that, no, you know what, you have to support peak load. How do you do that? That's the question we will be solving, because that's the real thing. In that case, there are multiple ways to do that. You can add, Lambda functions to do certain type of processing. I have a separate talk tomorrow just to talk about Lambda, AWS Lambda, serverless applications. You can come to that and get more information on that one. And then, if you want to know, how Uber is doing the same thing or Google is doing the same thing, I have another talk at the end of the talk tomorrow, 1 hour full dedicated just for that. Yeah. So we'll look at that in more detail, but we'll solve this problem today. So the one which I'm discussing, we'll be discussing that and solving it today. Now people say that, hey, network, what can go wrong in a network? When I'm talking about a network, hey, just a microservice. See this. What's really happening is, I have one microservice here. Let's call this microservice customer. Customer microservice is there. It's calling order. What can go wrong? What can go wrong? Anyone? Huh? Connection timeout, initial connection, anything can go wrong here. So problem is that Amazon is not even going to look at your request less than 20 minutes. You can't even create a ticket at Amazon. Hey, my server is down. Even if that's their problem. Because they want you to make it resilient. So let me explain you. There are 8 places it can go wrong. What are those 8 places? These are the 8 places. Client is posting the request, whether it's validated or not, or post reply is coming, validation reply is coming. So these are different places it can go wrong. in a distributed network when we are really working on it. Now think about it. When we are working on this, you're going to do retry mechanism. Yeah? So your API, you need to implement retry, make sure that you are able to retry the other server, and then make sure this is done. Yes? So you're going to add this thing to really do all these things. Now it becomes big ball of mud when one microservice is calling another microservice, which is calling another microservice. Now think about it's been like 26, 24 times, yeah? 24 places it can go wrong. If that happens, you need a pattern, which is like a pub-sub pattern. You know, people say pub-sub pattern you can apply, and you can do filtering on top of it to really support these kind of problems, yeah? So we'll talk about how to fix these. Like I described the problem, we'll be fixing them in the next slides, okay? So what that means, you're going to apply the retry logic and all these things you're going to apply here. So how do we make it resilient? So that's the question. That's the question we are asking ourselves. How can I make myself resilient? Yeah. So how do we do that? To create the resilient architecture. Anyone can tell me like what is the resilient architecture? What does it mean? Resilient architecture, what does it mean? Anyone? Failures. Auto start, yeah? Self-heal. What else? Huh? Standby, okay. Okay, what else?
Faster risk management.
Huh?
Faster risk management. Like if
Faster. Okay. Load balancer, yeah? Huh? High availability. Yeah, that is something which we can think about. What else? Scalability, yeah. What is scalability?
Like when the traffic is more, it will scale up, or when the traffic is less, the server can
So that is one way to look at scalability. Okay, it might not be needed here, but that's okay. It's good to discuss this right now. So think about scalability in two terms from the architecture perspective. One is, hey, when the traffic is there, you're going up and down the traffic. That's fine. But what's the trend looks like? Whether trend is going up or down. So when you're designing for anything, you design for 3 to 5 years. Okay, so anything you design, the database you design for the capacity of 3 to 5 years. Okay, you're not designing just for now. So that's where the scalability, how the system will scale in next 3 to 5 years. What would be my data look like in 3 to 5 years? That is one thing which is important. But one thing which we did not talk about here is response time. S-P-O-N. Okay, lifetime coding. Okay, that's good. Response time is very important. See this, what's really happening is it needs to be less than 250 milliseconds. If it is more than 250 milliseconds, resilient architecture has no meaning attached to it. So that is one thing which I suggest we need to look at. Also maintainability, which is important. Another thing which is important from the resilient architecture is message driven. When I need to be message driven, I need to send it through message. That means the two systems do not need to know about each other. The two systems do not need to know about each other. So that's something which is important from our side. So that's where the elasticity comes in. That's where the message driven comes in this case. So let's take a look at another example. Now this is a unicorn Uber is there. So I'm trying to create a Uber ride now. Okay. So I'm going to create a Uber ride. So I'm sending the data out from here till here. The management service is going to first save the data. I'm good. Yes? We talked about this. That's a good thing to do. The second thing is then I need to now orchestrate. I need to send the data to all these places. Yes? That's what I need to do. So how do we do that? And I need to filter some records. I need to filter them. I need to filter these records and send this data across all these nodes. How do we do the filtering of the data and other things like this? So that's a question which comes in. How do we solve this problem? So maybe you can think about what? API. You can orchestrate through an API. Hey, I'm calling HTTP calls. Yeah, that you can do. That means you need to have an orchestration API which calls all these things, all these APIs. Yeah. Now, if you think about this, now what am I doing? I'm doing a fan out in this case. Now, if you see this, we talked about our pattern also. You're going to add a load balancer here. Yes. Why? Because if this service goes down, endpoint goes down, it needs to go to this endpoints. So what's happening is you're sending it here and you're sending it here also. Yeah. You're doing the load balancing here. Now what's happening is that you also need to do filtering in this case. But not only that, let's say my load is currently, I'm processing 50K. Now all of a sudden I got 500K. K requests is coming in. Now what I need to do is I need to increase the load balancer. I need to add more servers to it. Yeah, that's the way I can solve this problem. Yeah, this is a real problem. We can solve it this way. So we can do a fan out pattern. We can also do a filtering pattern to really solve this. So in order to do the fan out and filtering, what you can use is a topic. So pub sub is a good way to do that. So if I go in here, so let me go to SNS. So this is an example from AWS. Yeah, so I'm looking at an example from AWS. When the data is coming in, let's say the orders are coming in. I'm only interested in the order which is more than $100. I'm only interested in the order which has errors in it. Because if there is no error, I don't want to look at that data. Yeah. So in that case, what you can do, you can create the topics for yourself. So within that particular topic, now what you can do is you can subscribe. So there can be multiple subscribers. You can have multiple subscribers. You can have SMS message going out also if there is an error message in the system. And then you need to also have something called as a retry policy. You need to also protect the data, PII compliance. Yeah, you need to retry. In this case, I'm doing exponential backoff. See, that's what it's saying. It's saying exponential backoff I need to do, and then retry logic. And if it fails, you need to send it to a dead queue. So those things which I'm trying to do here as part of the pub sub model. And then once we do that, the only problem here is, that's why I'm very cautious about this pattern. The customer should be able to take it. Like the one which I talked about. If you get so many requests, is it push? So this is what is this called as a push model. Yeah. Another one will be a pull model, where I'm going to pull the values and get it through. So this is the push model. So we'll apply the pull model to it. Yeah. To solve another problem, which is with respect to when the data is coming in. Let's say 10x data came through. When the 10x data is coming in, now what's happening? Let me explain you. What's happening is when the 10x data, so this is a 10x model. 10x data is coming in, I'm sending it to the queue. Now what's happening is I am sending this, whatever data is coming from this orchestration, I'm sending it to a queue. Now queue is processing, this service is pulling the data, process the record from the queue, and then go to the next one. Now what happens? This is acting as a buffered load balancer. So in that case, you don't have to scale out the latency. So this is where the scale out latency you can't do. So in that case, you have to provide some mechanism to support it. That's where you're going to add a queue to support that model. Make sense? So this is the pull model which you can apply to your integration pattern to solve this problem. Yeah. Any questions on this? We are good on this one. Yeah. So this is the model which is typically used by many companies to really support how we do the buffered load balancing. Okay. Now you can also try using a Kafka stream or a Kinesis stream. So you can do a Kafka or Kinesis stream where you can replay that same event again and again and process it. So there are two models. Either you use a queue or a Kafka stream. Queue is useful if you have, let's say, you have got 20,000 requests per second coming. Queue is fine. 100,000 requests coming per second. How can you fix that? Let's say you're using a queue. 100,000 requests coming per second. What can you do? Anyone?
Consumer scalable.
You can scale up consumer, that's one thing, but queue cannot handle more than 20,000 requests per second. You cannot. I mean, there's a limitation in queue. I'm discussing limitation. RabbitMQ, if you add, it cannot do more than 20,000 requests per second. So, huh? Huh? Yes, I'm coming to Kafka also, but if you need to solve this through queue or through Kafka, doesn't matter. You can use with Kafka the same principle I'm talking here. Partitioning the data, yeah. So once you partition it, where are you going to partition the data? Huh? In the queue? Yeah, so what you can do, even if, before you even enter the queue, from here itself, let's say Uber I'm talking about, Uber will send it to a data center in India when they are processing requests from India. Uber will send it to a data center in New York when they are processing the US transactions, yes? So this is another way you can scale up where you are bifurcating the queue into different regions. So you are actually going down. Let's say New Delhi or Bangalore, they have like so many Uber drivers are there or so many things you have to do. What can you do? You can partition it more. That is another way to do that. While the data is in motion, yes? You can do it while the data is in motion. You can also do it while the data is at rest. That means do the partitioning at the database level. So you can do both the partitioning to really solve that particular problem. Okay. All right. So that is another thing you can do. Like you can put the data here and then be able to use that. Now what we're going to talk about is how do we link the data? Because we talked about, we started with like understanding the architecture. Yes. You can create multiple queues, yeah? You can create multiple queues for different topics, you can create it, yeah. Absolutely, you can do that. But now what's happening is there is another thing. This is not part of this, but I can talk about it, you're asking it. So what you can do is, you can add something called as attribute based. Let me add that here, okay? Huh? Filter, you can say attribute. Attribute based queue. Attribute based queue means you are adding the filtering right here, saying that this is the tenant ID. Based on the tenant ID, you are sending it to the right place. So you are creating something called a hash map. Hash map of tenant ID, and this tenant ID is supported by this pod. You can do that, and actually Twitter does that. Twitter exactly does that architecture to support that kind of load which is coming to it. Because Twitter supports like millions of 500,000 tweets are happening per minute. How they support it? Like 1 million tweets can happen per minute. So how do they support it? Like we'll talk about it tomorrow if we get time more. Okay. So now what we're going to talk about is how do we linking all these data. Linking data is important. We need to link the data and it has to be performant. Performant and linking the data. How multiple systems are linked to each other? That's a very good question. You don't want this. You know what is this? Huh? Spaghetti, yeah? Yeah, I can say this is spaghetti, definitely. But really, what is this? A brave person who first started doing the integration, they wrote a Java code. And they said that, oh, I need to integrate with SAP. Yes? They created point-to-point integrations. When you create point-to-point integration, that's what it looks like. And you can't even change anything. You're afraid to change it because it's like so vulnerable in terms of its usage. So that's what the model is which is coming in. You need more abstraction here. And I'll talk about multiple ways of doing that abstraction. So one other thing is how do you design the workload? Workload is coming in. Whenever something is coming from the internet, how that thing should come through the cloud front. So what really happens is, let me explain you what really happens. So what happens whenever any request comes in? What happens first when any request comes in? What happens? It goes through DNS, domain name server. What does it do? Huh? What? It returns the IP address, okay, and then what happens? No, it's not with all the server. I'm looking for something. Routing. It does the routing. It does the routing of the traffic. When it does the routing of through the internet, it does the routing of the traffic. Yeah. When it is doing the routing of the traffic, it's basically what you're saying is that it's now sending it to something called as CDN. Yeah. CDN. Yeah. So before CDN, Route 53. After that, CDN comes. What CDN does? Now you talked about something here. Yeah. What does CDN do? It identifies the closest server and send the routing the traffic to that server. Before that, you can do some of the routing in here also in the IP-based routing, and you don't send the traffic across, yeah, all the nodes. So you're using the CDN, you're routing the traffic using CDN, and you're also doing TLS. Yes, TLS operation you're doing here. And then SSL, basically you're doing SSL encryption you're doing. Not only that, what you're doing here? WAF. Web application firewall. That means SQL injection attack somebody is doing that. That's what you're doing in this case. So that's where the CloudFront comes in. And then the API gateway comes in. Now you're routing the traffic to the VIP customer, which you're trying to perform. And you can cache the data here also. Now you're sending it to the endpoint, which is available, which is internal endpoint. Now, why I'm saying that? This is your internal server is there. Why I'm saying that route through API gateway, now you can throttle it. You can add all the things which you can't do otherwise, you know. So that means you can do throttling here. Throttling here, yeah. You can say that you're not allowed to send 5,000 requests at the same time, you know, things like that. You can cache the data also at the same time, yeah. So that's one thing you can do here. Another thing is you can add serverless operations. You can create a Lambda function, which is also serverless. Now you can scale as much as you want. Like, you know, Lambda, you know, as many containers as you want, you can create it here. Now, distributed system, when we are trying to add, one other thing which you have to be careful about it is disaster will take place. You have two systems. Okay. System 1 is there. So system 1 is here, and system 2 is here. Yeah? System 1 send the data out. System 2 received that data. Now what happens? Disaster took place. They lost the data. How do you recover from that data? How do you recover from that data? Anyone? How do I recover from the data? Huh? Data backup. We should do a backup. What else? What else? So I have a DevSecOps talk, which is sometime coming later, where you need to actually do something called as MTTD. MTTD. Yeah? What is this? Mean time to detect. Yeah? You need to know there is a failure. That's the first thing you need to do. If you don't know, you can't even recover. Na? You lost the transaction, but somebody needs to tell you. QA, see, this is what happened. Developers code, they send it to QA. And then they're relaxing. And then the bug comes. That is MTTD. Ideally, developers should have found that bug beforehand, before it going to the QA. But we find out in production, oh, something went wrong. And the faster we find out, we're going to find out how many transactions we lost. When we lost that transaction, how do we get that transaction back is important. Yeah? In that case, all your APIs need to support what? What does? Huh? What? Not retry. You need to support some, we call delta load. Delta load means, give me all the transaction in last 4 hours, whatever happened to you. Yeah, archiving, you can say archive, but you have the same API. You have the same API. Order API is the same. Give me all the orders from last 4 hours. Delta load. So if you're not supporting delta load, you need to support it. That is important. If you're not doing it now, start doing it right away. That will help you out. Then you're not just relying on Kafka to really do it for you. Because Kafka can't sustain, like, you can't keep the data for a long time. You can do lifetime, but like no more than 1 or 2 days you can keep, yeah. There is a retention policy involved there, but then retention policy is not the only thing. Like Kafka is keeping a stream of data coming to you. You know, you have to recreate that data. I'm telling you a cheap solution. Like I suggest use Kafka. You know, it's a good architecture to use, but you still need to have the delta load. So people can use Kafka if you need to use Kafka, or use delta load. So that's one thing which I suggest doing. So there will always be a recovery point objective and time objective. You need to know what is this for your application. And if you get a failure, you need to be able to inform the customer there is a problem. So this is an example of, hey, I don't have the product with me. Supply chain problems. Yeah. If you don't have the product, then refund the customer. Yeah, that's what we get the refund. Or you're going to get it after few weeks of you're going to get the data. Another thing is like, this is another domain I'm talking about. Now what happens to the customer? Let me ask you a question. Now this is the integration bias, by the way. Customer, think about this as a customer. Think about this as another system. You remember like, now mesh is coming up, service mesh is coming up. You are adding payment gateway which is providing all the details. Think about this system is contacting other systems to find out how to fix this problem. Yeah, that's what you're doing. You're creating an intelligent system for yourself. Okay, tell me, somebody calls by phone, email, ticketing, which one out of these is cheapest? Email is the cheapest? Anyone else? Ticketing? What else? See this, knowledge base. Yeah, knowledge base, KB. So what you can do is, you get an error message, you create a knowledge base for it. Yeah, so whenever you get an email, you get a suggested, hey, this is the knowledge base, you should look at and fix that issue. So if you are on phone, that is the highest cost. Now, there are other software which are coming in, which is providing a support, but you need to revert it to the customer. So what is this? This is where you're going to get the customer satisfaction. CSAT will increase in this case. Yeah. So that is another domain which comes in like integration wise when you're working on it. So that means you're trying to create swim lanes. Swim lanes means one system is a patient system, the CRM you can call it, and doctor is a ERP system. It doesn't matter. You are maintaining, what are you maintaining? See the doctor, another thing. What is this? States of a data flow, how the data is flowing between the two systems, which state the system is. You're ordering a pizza, where is my product at any given time? You're ordering a bike, where is the product in the supply chain? You can actually go in, you can try this out. Go to Amazon, when the product is getting delivered, you can actually do the tracking. Even if they're using UPS and other systems, you can actually track the data, how this is coming through. So you need to know how the data is flowing from one system to another system, and then be able to have a way of finding issues whenever they happen between them. That's where you create the resilient architecture. Make sense? And that's the reason CQRS is used. CQRS is command query request segregation. What this is saying, and I think some people are using that, yes, as part of your solution. What you're doing is you're storing all the data in the database. Whenever somebody is saving the data, let's say order, I save the order here. But at that same time, I'm sending that order through raw event sourcing that data out. I raw event source the data. I send that order out, so it's materialized view ready to go, created for them. Now, how do we use that in multiple systems? We'll talk about that. How do we do that without writing a single line of code? I'll talk about that. Yeah. So let's talk about that. So you can use Kafka Stream. That, by the way, people were saying, hey, you can use Kafka, where you have a producer and a consumer. The good thing is, producer do not know who the consumer is. That's the important thing. If you know, that means you're doing point-to-point. That means you're doing point-to-point. So what happens, whenever something comes in Salesforce or Microsoft, something comes in, like, an order comes in, we need to send the data to SAP, to Workday, and Oracle. Yeah? What that means, whenever an order is created here, see, we talked about it, it's repetition, order. Now order is created. This order, after it transferred to here, then all the updates through the order can only happen in SAP, not in Salesforce. Yeah, so that's an important thing to keep in mind. That's where the event-driven architecture comes in. So what you can do is, how do I synchronize the data without writing a single line of code? What you can do is, you can do something called as change data capture. Change data capture is a mechanism which is supported by pretty much all the databases. Anybody here use SQL Server? Oracle? You know, MySQL, other databases are there. So you can use any of that database to really support that. So that means you're getting all these things out from yourself and sending the data. So CDC is supported by all of them. You use the CDC, it will give you a transaction ID where it's saying that, okay, this is the employee ID, create, and then you're sending the whole blob of data with the replay ID, saying that, hey, you replayed like this. Now what's happening is, once we create the replay ID, now consumers can consume this in multiple orders. Like consumer B can consume it faster than consumer A. Yeah? So that's, for example, order is triggered, you publish that order to the bus. Now when the shipping is being done, I'm publishing it back to the bus and then I'm updating the order. So both the systems don't know about each other, what's happening. Yeah? So that's the advantage, how to do this, to implement in multiple languages for all the UIs which have been given to you. What standard should I use to do that? Yes, that's the question which we have got. In that case, you could use commit-D protocol. What commit-D protocol is saying is that, you know, highly scalable clustered web messaging you can do with this. What that means, it's HTTP based. It can use WebSocket to push the data between the two different servers. So you can easily be able to get the live data pushed across different systems. Yeah. So you can use this protocol to do that. So what that means, you can use Java or C# or any tool to really do that. So that's the reason this is very powerful. I suggest you guys to look at it. So I have one example here. So I'm creating a chat app. So I'm going to put here hello. So I put yes from here. Now I should be able to see other chat app which is written in different language, be able to pick that at that same time. So that means the data can reside only in, so sometime you have, anybody here has data residency requirements? Data residency requirements. That means if Russia or China, the data has to reside there. India, data has to reside here. So how can you implement that solution? By using commit-D protocol, and also you can add on that is through the REST protocol, you can actually save it, and then data is always residing in one system, but another system just viewing that data. You can use this particular protocol to do that. Okay. So when you are going through the SaaS journey, this is another thing which kind of comes in, where you're either development mode and other mode. So you have to predict how you create the system. Like, whether it's a system when you're trying to create, you're going to recreate that system, or you want to adapt to a newer model. So your monolithic application is converted into microservices. How do you do that? Like, cloud adoption model, you can kind of pick from this particular solution at the end. So this is, let me show you this for a second, and then we'll move on. So this is saying you rehost it, and then automate all the systems, or you use another vendor to do it. So there are 4 or 5 options are there to move from in-house system to the cloud. Yeah. So that's one thing which you have to keep in mind. One more important thing is that if the data is residing in only one system, which is the master system, in that case you can create external IDs. Yeah. You keep the external ID of the other system in your system. Yeah. If you need to do bidirectional sync between the two systems, in that case, what you need to do, you need to make sure that one system is keeping record of duplicate management. Okay? One system is keeping record of what? Duplicate management, and then be able to support that. So that's what you have to do in this case. MDM solution wise, one thing you have to keep in mind when you are building the MDM solution. The important thing is, because the data needs to be secure. Data needs to be in one system. So you want to make sure that you do address cleaning. And there are, by the way, services which does address cleaning for yourself. One of the services, DNB. Anybody know Duns and Bradstreet? So Duns and Bradstreet is one of the service which is there where you can actually go in and find out, because 150 businesses change every hour. CEOs change, so it doesn't matter. So whenever they change, Duns and Bradstreet, if you're doing B2B, your data is stale after 1 minute or 1 hour. So you need to always go to DNB and get the data and then be able to process that. So that's one thing you can do using DNB. And another thing you can do is you can save the data. Let me show you one more diagram, which is kind of an important one to understand. Yeah, so let me show you this diagram and then we'll be ending around here. So what's really happening is you want to make sure that you have an asset. So an asset can be you're selling it to a B2C, B2B2C. So you are building B2B2C or B2B infrastructure, yeah? So that's what you're trying to do here. And then you are working with the influencer to really sell your product. That's what you're doing here, yeah? So what that means, the vendor you can create a MDM solution for the product and start using that, yeah? So that's what the advantage of creating a multi-domain MDM solution when you're trying to build in this case, okay? So that is one thing very important for you to have. Now, when you're storing the data, single source of truth, the important thing is some data is residing in CRM, ERP, PLM. See, customer name is the same, see? But CRM is a single source of truth, SSOT, when something changed on this one. So that's what you need to know, which one is a single source of truth, and then use that for your particular system when you're building it, okay? So when you build the system, the important thing is, another thing is the security. So that means GDPR compliance. How many here has to do GDPR compliance, yeah? That is another where you want to be able to delete the data, legitimate purpose for deleting the data. That means somebody can call you anytime, say, I want to delete the data. You should be able to delete the data, right to be informed of all the data. Always doing ISET. That's what you do, yeah? So that's exactly what you're doing in this case. That's where the personal information comes in, which we call it as a PII compliance. So we'll kind of end around this part, so which is important for you to understand. Now the problem is, how do you identify PII data? That's very important to understand. How many here have done data classification? What is data classification? Huh? You are trying to find out what's the important data, what is not an important data. And other thing, what are you doing in that case? Anyone else? Yeah?
Can we use that data for third parties?
Third parties, who's the owner of the data? So what happens is, like product owner says that, hey, I want to change this thing. The first thing comes in, if I change it, who is impacted? You don't know. Yes? If you know the owner of the data, that's where the data classification comes in. So you need to do data classification of all the fields which are there in the system, and then also identify the sensitive data and encrypt the sensitive data at rest. Yeah, when the data is at rest, you're going to encrypt that data. When we encrypt that data, what happens? When I'm searching for that data, let's say I'm searching for that data, I can only search for the whole social security number. I cannot search for 345 star. That's not allowed. That means you need to do deterministic encryption. Yeah? But let's say somebody put a comment in place, which is a PII data, can be a PII data. In that case, what do you need to do? You don't allow the search. Because by law, you are not allowed to search the data, which is the comments, because if something is having PII data, you can't search that. So something important to understand when you're working on it. Well, today's journey was, we started with enterprise architecture. We looked at it. What are the how these systems are integrating with each other. We found out the problem, saving the data, and doing the fan-out pattern, looked at the integration patterns, how to create resilient architectures, we looked at that, and how do we link the data. How do we link the data without writing a single line of code? Yeah, we talked about it. And at the end, I touched on the important part on the MDM as a solution. All right. So I hope you guys enjoyed the session, and I'm here for any questions for you guys. But thank you so much for your time, and connect with me anytime for any questions. Connect with me on LinkedIn. You know, that is the best way to reach me, and I should be able to sync up with you guys. If you have any questions, I can answer you as needed. All right. Thank you guys.